All right, so we mentioned what vertical asymptotes are and what horizontal asymptotes are, and we want to be able to find vertical asymptotes and horizontal asymptotes for our rational functions. So let's say we have a rational function of the form r of x equals p of x on top. So p of x is a polynomial on top. And on bottom, you have a factor of x minus c. So x minus c is a factor times q of x, where q of x is another polynomial, some other combination of factors. That means that the function r, the rational function r, has a vertical asymptote, at x equals c. So what did we basically do? We took this factor right here. So the idea is you take the factor on bottom, right? X minus c on bottom. You set it equal to 0, and you solve for x, right? You just add c to both sides, and you get x equals c. So that's basically what we're going to do. We're going to factor our denominator, and set our factors equal to 0, and those will give us all the vertical asymptotes of our rational functions. Okay, so I'll just do an example real quick. Let's say I have the following. R of x equals 9x squared plus 9 over, x squared minus 5x. What else? Minus 50. Okay? And let's just find the vertical asymptote here. I'll say vertical asymptotes, plural. We may have one, or we may have more than one. So what we're going to do, we're just going to take the bottom and set it equal to 0, basically. Set it equal to 0. So, or wait, let's factor it first. I like factoring first. So I'm going to take the bottom here. Can I get this? There it goes. And we're going to factor that. So on top, I'll just leave alone, for now, 9x squared plus 9. I'll leave that alone. I'm going to factor the bottom. So that's going to be 2 sets of parentheses, right? We're going to have an x times an x to get squared, and then you're going to find two numbers that what? Multiply to give negative 50 and add to give negative 5. And your numbers are what? Negative 10 and positive 5, right? Negative 10 and positive 5 multiply to give negative 50 and add to give negative 5. So I'll write those and negative 10, positive 5. So now I'm going to take each of my factors. So I got two factors here, right? Two factors here. I'm going to set them equal to 0. X minus 10 equals 0. The other one is x plus 5 equals 0. I set those equal to 0, and the first one, I'm going to add 10 to both sides. I get 10 as a vertical asymptote. And my second one, I'm going to subtract 5 from both sides. I'm going to get x equals negative 5 as another vertical asymptote. So here I actually have two vertical asymptotes. Yeah. So basically, you're taking your denominator, factoring it, and then taking each factor and setting those equal to 0 to get the vertical asymptotes. All right, so it's not a very difficult process. Let's look at horizontal asymptotes, how to find those. So we talked about what they are graphically. Now let's talk about how do you find them analytically. Just going to write here, finding horizontal asymptotes. For rational functions. Okay, so let's say we have a rational function. Let's call it r. Let r be the rational function r of x equals, and let's say on top I'm going to write my polynomial as follows: an x to the n plus an x to the n minus 1, so on and so forth. a2x squared plus a1x plus a0. So I have a polynomial on top, and remember you have a polynomial on bottom. I'm going to write this in the form bm x to the m plus bm minus 1 x to the m minus 1, so on and so forth. b2x squared plus b1x plus b0. So on top I have a polynomial. On bottom I have a polynomial. So that's my rational function, right? That's what a rational function is. You have a polynomial on top, polynomial on bottom. So we're going to have three different cases we're going to look at to figure out horizontal asymptotes. Number one, if the degree of the top, which is n, right? That's the degree of the top. That's this one right here. If that is less than the degree of the bottom, which we're going to call m. So if the degree of the top is smaller than the degree of the bottom, then the function r has a horizontal asymptote at y equals 0. Y equals 0. That's your first case. So if you have a smaller degree on top than on bottom when you're looking at your polynomials, you automatically have a horizontal asymptote at y equals 0. What if they're the same? What if the degree of the top is equal to the degree of the bottom? Then that means r has a horizontal asymptote at, and you're going to use y equals an over bn. So basically you're going to take the top leading coefficient divided by the bottom coefficient, take the ratio of those. So the ratio of the leading coefficients, top over the bottom. So that'll be your horizontal asymptote when the degree of the top is the same as the degree of the bottom. Now there's a third case. What happens if the degree of the top is bigger than the degree of the bottom? So your top polynomial has a largest power larger than the bottom's largest power. What happens with that case? Then r has no horizontal asymptote. Now basically these three cases. Degree of the top is smaller than the degree of the bottom. You have a horizontal asymptote at y equals 0. If the degrees of the top and the degrees of the bottom are the same, you have a horizontal asymptote at y equals the ratio of the leading coefficients. And if the degree of the if the degree of the top is bigger, the degree of the top is bigger than the degree of the bottom, then you don't have a horizontal asymptote. So, very important. So I'll do some, quick examples of finding horizontal asymptotes. Let's say we have r of x equals 3x squared minus 7x plus 9. And on bottom we have 8x to the 4th minus 9x squared plus 1. So let's look at the horizontal asymptotes. Now it turns out when you're dealing with rational functions, if you do have a horizontal asymptote, there will only ever be one with rational functions. You won't have more than one with rational functions. Now there are other weird functions out there that could have more than one horizontal asymptote. With rational functions, you'll just have one. Okay, so basically we're going to look at the degree of the top. I'm going to call that the degree of p of x. I'm going to call the top one p of x. That's 2. how does that compare to the degree of the bottom? I'll call that Q of X. That's 4? Okay, degree of the top is smaller then, right? Smaller than degree of the bottom. So I'm going to say since the degree of the top is smaller than the degree of the bottom, then there is a horizontal asymptote at y equals 0. At y equals 0, yeah, so when the top has a smaller degree than the bottom, you have a horizontal asymptote at y equals 0. Let's do a number 2 situation. Let's say we have a rational function x to the 7th plus x to the 6th minus 9x to the 5th. On top and on bottom we have x to the 4th minus x to the 3rd plus x squared. We're going to look at our top and our bottom degree for our horizontal asymptote. Okay, so on top you have a degree of 7, so I'm going to call that the degree of p of x. That's 7. And on bottom you have a degree of 4. Q of x as a degree of 4. Now it turns out that this time the top has a larger degree, right, than the bottom. So I'm going to say since the degree of the top is larger than the degree of the bottom, then there is no horizontal asymptote. Then there is no horizontal asymptote. All right, let's do one more example here. Number 3. Let's say we have, I don't know. Let's say we have negative 5x to the 3rd minus 6x squared plus 9x plus 1 on top and on bottom. Let's say we have 10x cubed plus 8x squared plus 20. And we want to look into the horizontal asymptotes, or the horizontal asymptote. Let's see if there is one. And if there is one, let's try to find it. So first I'm going to look at the degree of the top. I'm going to call the top p of x. The degree of the top here is 3. Let's look at the degree of the bottom. I'm going to call that q of x. The degree of the bottom is 3 as well. Hey, they are equal, right? They're equal. Forgot to write 3 here. So since the degree of the top is 3 and the degree of the bottom is 3, they're the same, then that means there is a horizontal asymptote at y equals, so you're going to take the ratio of the leading coefficients. The ratio of the leading coefficients. So I'm going to take negative 5 over 10. Negative 5 over 10. So what does that reduce to? That's y equals, so divide 5 out of the top and 5 out of the bottom, you get negative 1 over 2. So there's a horizontal asymptote at negative 1/2. Y equals negative 1/2. All right. Oh, those are the general procedures you'll want to use for finding your vertical and horizontal asymptotes. What else do we want to do?